What's up guys, in this tutorial we are going to implement the first set interface which is called as an HashSet. So to do that, what I'm going to do is inside this demo package I'm going to create a new package called as sets, right? And inside the sets I'm going to create a new class called as HashSet demo, right? And let's create our main method here. So to define an HashSet, what you have to do is I'm going to use set, and this will actually hold, let's say, string value. I'm going to name this as the names is equals to new of HashSet, right? So what here I did is I've created an instance of set HashSet, because as HashSet actually implements the set interface, so I can create an instance here, right? So I can actually create, this is basically creating an HashSet instance. So if you see here HashSet, internally it maintains HashMap. As you have learned about HashMap, that HashMap can have only unique keys. So based on that, this HashSet is created. So let's add some of the methods here. So I'm going to add, let's say, John, right? I'm going to again add, let's say, Henry, the same old, right? So I can also add, let's say, Trump, example. I'm going to, let's say, I want to add again, let's say, John, right? So let's do the S out and let's print the names here. So what I'm going to do is I'm going to run this code, and if you notice, you will have the output as John, Henry, and Trump. As you have been adding John 2 times, this will not be added because the set actually cannot contain the duplicates. So this is what it actually implies, that the hash set doesn't have any duplicates here. So this is what about the hash set is, right? So as internally hash set, you know, implements the hash table, it has in one of its constructor as initial capacity and a load factor. So the default load factor is 0.75f and the initial capacity is 16. So if you notice, if you go into this add method, so this add method is actually adding in an hash map, right? So if you go here, hash set, and if you see the add method here, so this is actually putting inside the hash map. And as the hash map can have only unique elements, that's why it is able to um, basically it is able to have the unique data, right? So if you see here map.put, this is the key is nothing but the element we have passed in an add method, and this is basically just a simple object. So if you notice, this is an object instance, right? And it actually checks for null, right? So if map.put operation is null, if it's true, then add operation is success. If it's false, then add operation is it did not success. So for example, if you put a key value, let's say John, right? So this will be true. So add operation is successful. Again, if you put Henry and then again you try to put a John, this will fail, and here it will return the false. So for example, if I try to print out, let's say here s out, so I'm going to do an s out on this uh, add method on John, and when I run this code, you'll notice as add method returns a boolean type, you will notice that this has been failed because John has been already added, right? So this is what it actually means. So also there are various other methods provided by an HashSet. So for example, you have added the here for example the names. You can, let's say, create one more HashSet, and this will be a string, and let's say that I'm going to name this as names1 is equals to new of HashSet. Remember that you could also use set, or you could also create an HashSet instance, and you could do something like this: names one that add all. You could add all names here, and if you try to print out the names one, It will have the same content as the name's content, right? So this has the same content as name constant. And let's add inside this name, you can also try to add, let's say Michael. And when you run this code, you'll notice you'll have one more entry called as, you know, Michael, John, Henry, and Trump, right? So as it internally maintains, the hash map, so the insertion order is not maintained. This is one of the thing you should always remember. Whatever elements you add inside a set, the insertion order is not maintained. Remember that, and you have seen that when you implemented the hash map also. So let's see some of the mathematical operation inside an hash map. So before that, let's try to access, the elements of an hash set. So what I could do is names one dot. Let's see if there is a get. So there is no get operation, right? So as an hash set implements the set interface doesn't have get operation, right? So that's why we don't have a get. So the best way is to create an iterator object, as this is a string. So I'm actually creating an iterator here. So names one dot iterator. So I'll iterate through this while iterator dot has next. I'm going to actually print out iterator dot next, right? Iterator dot next. So let's print out each element using an iterator. So if you notice, it actually printing out each element using an iterator, right? So this is how you can actually access the elements here. How do you remove an element? So remember, when you did, let's say, an array list implement, so I'm going to use the names one object, and when you do a remove, it actually accepts, let's go into this method. So it actually accepts the object, not the index. Remember this. So whatever you have added here, if you want to remove, let's say Henry, so you could do that using this, right? So this is not actually accepting any integer value. So this is not removing based on index, right? And there is a very good reason, as the insertion order is not maintained, so that you cannot pass the index, right? So you need to pass the object to remove that object from the set. So let's do that. And if you try to print out the names one, you'll have an updated hash set without the entry as Henry. Remember that. Also, there are other methods, like for example, you could do the union of set. So we have done that when we did an add all. The add all operation is basically the union of set, right? So let's do the intersection of sets. So what is an intersection? Intersection is basically, let's say that you have two hash set. Let's say, for example, not hash set, but let's say you have two sets. And what is the intersection of two sets? So whatever is the common element existing between them, it's called as the intersection. So for example, what I'm going to do here is I have removed the Henry here. So I have created a new hash set. I've added the Michael here, and I already have, let's say, I'm going to add a Trump here, right? So I'm adding a Trump here, not here, but let's say I'll add below this. So I'm adding a Trump here, and let's do names one dot retain all. So I have created a new, you know, um, hash set. So I'm going to use the old one. So this is the new hash set and this is the old hash set. So when you do a retain all operation, if you go inside this, so this is basically perform the intersection between the two sets. So if you see here, we have here Trump and the initial original array has a Trump. So the output of this operation will be, a single element as Trump, because Trump exists between the two sets. So if you notice, okay, so basically I need to do that operation first. So what I'm going to do is I'm going to remove this. I'm going to perform the operation, and then I'm going to print the names one. So as retain all is actually returning the Boolean operation. So let's run this code again. So when I run this code, you'll notice that the names one has John and Trump. This is because you have a Trump in names one, right? So names one, we did an add all here, right? And when we printed this, we have Michael, John, and Trump, and we originally have John and Trump, right? So the original set has, so we have two sets here. The first set has John, Henry, and Trump. The second set, which is names one, has Michael, John, and Trump, right? So Henry has been removed. So if you do the intersection between the two sets, so the John and Trump are common, and that's the intersection we have. So retain all operation actually performs the intersection between the two sets, right? Remember that. Also, you could do, the other operation as well. You could, can check the subset. Subset, it's like, if, let's say for example, let's try to print out names one dot contents. Let's say that names. If you notice, it should return true because it has a subset. Okay, so this is returning false because to check if a set is a subset of another set or not, we can use contains all method. For example, what does actually subset means is it should actually have, the common element. So I think by logic it should have written the, so inside this we did a retains all. So if names one contains names, so let's try to do some debugging here. Right now we need to actually check if we are correct here. Okay, so it's not contains, it's basically contains all. To do, Uh, to do a subset, you actually needs to do a contains all, not contains. So there's a two different method. So what I'm going to do is I'm going to run this, and this should actually return true, right? Okay, so this is still returning false. I don't know why. So it has John and Trump, right? The names one has John and Trumps. Let's try to print out, the name, and let's run this code. So this has John, Henry, and Trump. This has John and Trump. So contains all will return false because is this a subset of the two sets? I think it should have been the case. Okay, it's because the names one has two data as well, but the names has three data, so it should have been the other way around. So instead of names, you should have names one. So names has more data than the names one set. So I'm going to run this code again, and now it's coming as true. So the names and the names one, is there a subset between the two sets? Yes, it is there. And you should you should do contains all in such a way that this set should have more elements than this set, right? So this comes down to the mathematical model of sets. So if you want to learn more about this, you can go on the internet and check for the intersection union, you know the subset of sets and all operation, and when you try to do that operation using an HashSet, you will see the similarity between the two. So this is where I'm going to uh, cut this video, because it's this is what the set interface is all about. So in the next tutorial, I'm going to come up with a new collection related to set. Till then, goodbye and see you.